these are your video notes on the Pythagorean theorem. We're going to start off with looking at what the Pythagorean theorem is and how to set it up. So in a right triangle, you're going to have two legs. The legs are the ones that form the right angle. And then the third side, the one that's opposite of your right angle, that is called the hypotenuse. So the two legs are typically labeled A and B. The hypotenuse is typically labeled C. The Pythagorean theorem says that in a right triangle, if you add A squared plus B squared, that is going to equal C squared. And we can use this to solve for missing side lengths. It would be a good idea for you to have a reference of your common squares. You could either copy down a chart like this, or you could use a multiplication chart, but some of them are going to be pretty common, and it's helpful to just have a chart so you don't have to rework them out every single time. All right, let's look at how to actually find a missing side length using the Pythagorean theorem. So we'll still use our four-step process, which says that we're going to start with the equation. Also, it would be a good idea to label the legs A and B. The hypotenuse is already labeled C. So for step one, A squared plus B squared is equal to C squared. And then I'm going to go ahead and just substitute in everything that they gave me, and then fill in the rest of the equation. All right, from here, 5 squared is 25, 12 squared is 144, and that's going to equal C squared. So 25 plus 144 is 169. That's equal to C squared. And then to show the step on undoing the squared, I'm going to take the square root of both sides. So to undo C squared, I can do the square root, and that's just going to equal C. And then the square root of 169 is going to be 13. Since we're talking about a distance, we really only care about the positive square root and not the negative. And then finally, we're going to put units on that. So our missing side length is 13 meters. It also would be good if you did a quick check. Your hypotenuse is always going to be the longest side. So if I were to get something that was unreasonable, this would be a good place to figure that out. All right, next one, we have side lengths. The legs are 8 and 15, so we'll start with the Pythagorean theorem. A squared plus B squared equals C squared. A is 8, B is 15, and that's going to equal C squared when you add it up. So 8 squared, 8 times 8 is 64. 15 times 15 is 225. When you add those together, you're going to get 289 is equal to C squared. And then we're going to show that we'll square root both sides. So the square root of 289 is 17. The square root of C squared is C, and units are going to be feet. All right, next example, this time they've given us some different information. So the legs are A and B, and this time they gave us the hypotenuse instead of both the legs. So just like before, we'll start with our formula, and then when we plug it in, we're just going to make sure everything goes in the correct spot. So A is 16. We don't know what B is, so we'll leave that as B, and then C is 34. So we'll simplify the things we know. 16 squared is 256, and 34 squared, I've already worked that one out, is 1,156. Now this time we can't just combine like terms because they're not on the same side of the equation. So I'm going to subtract 256 from both sides. So 0 pairs And I get b squared is equal to 900. And then just like before, square root both sides. Square root of b squared is b. The square root of 900 is 30. And the units I need will be yards. So b equals 30 yards. And that would make sense based on the picture. It should be less than 34 since the hypotenuse needs to be the longest of the three sides. All right, another example kind of similar to that. This one just includes some decimals, but we'll set it up the same way. A squared plus b squared equals c squared. We don't know what a is. B is going to be the other leg that forms the right angle, and then opposite of the right angle is the hypotenuse, which will be C. So 2 and 1/10 squared equals 2 and 9/10 squared. You can do 21 times 21 and then just adjust your decimal point. Same thing, 29 times 29, especially if you have your chart already set up. So 2.1 squared is 4.41. 2.9 squared is 8.41. And then just like the last example, subtract 4.41 from both sides. Here's 0 pairs, and you're left with a squared is equal to 4. So we'll go ahead and show square root on both sides and get a is equal to 2 centimeters. And then when we plug that in, that would be reasonable. It's less than 2.9, which it should be for the length of a leg. All right, next we have a right triangle formed between a tree trunk, the ground, and a wire that is supporting the tree. So set it up just like our other ones. A squared plus b squared equals c squared. C isn't labeled, so I'll go ahead and add that to the diagram. So I'll do 1 and 5/10 squared plus 2 and 5/10 squared is equal to c squared. 15 times 15 is 225. And so 1.5 squared would be 2.25. Same thing, 25 times 25 is 625. So 2.5 times 2.5 is 6.25. That equals c squared. All right, we'll go ahead and combine these. That's going to be 8 and 5/10 equal to c squared. Now this does not have a perfect square. If we think about our chart, we have 1 squared is 1, 2 squared is 4, 3 squared is 9. So 8.5 is going to be pretty close to 9. So if I had to estimate, I'd say somewhere around 2.8 or 2.9 because it's just a little bit less than 9. If we plug that into a calculator, so I'll still show square root on both sides. If you plug that into a calculator, you're going to get about 2.91547 something something something. I'll go ahead and just round to the tenths place, and units would be feet. So something like that you could estimate just by using what it's closest to out of the squares that you do know, or if it's a calculator problem, you could plug that into a calculator. All right, last example for your notes. This time we're going to need to use the Pythagorean theorem twice in order to get our missing side length of x. So I'm going to start with this triangle because that is a triangle I can actually solve. I've got A, B, and C. So just using that triangle in blue, we can solve for B. So 5 squared plus b squared is 13 squared. 13 times 13 would be 169. We'll subtract 25 from both sides. And that's going to give us b squared is 144. Square root of both sides. Notice I'm doing this in a separate color. That will be a step you'll need to show on any test or quiz or homework assignment. So we get b equals 12. And then I'll put units back on at the end, but for now I can put 12 right there. And that seems reasonable. It's less than the hypotenuse, and it appears that that would be the correct value based on the figure. Now that I have that measurement, now I can use that in this triangle to get my missing side length. So start with the formula. We'll go ahead and say that this is now A, so I'll do 35 squared plus 12 squared, and then they used x, so I can plug in x squared. That part isn't super important, but I'll try to be consistent with what the formula looks like. All right, so 35 squared is 1,225. 12 squared is 144. That added together equals x squared. When you combine those, you get 1,369. And then we'll do the square root of both sides. Square root of x squared is x. Square root of 1,369 is 37. And that's going to be in millimeters. And then when I put that back in, that would be reasonable since my longest leg is 35. The hypotenuse would have to be a little bit longer. All right, those are your notes on Pythagorean theorem. I'll leave that there in case you want to get any of your squares written down. Thanks for watching.